welcome to Chapter 15, Section 10, and we're finished with Chapter 15, so we're finished on, just on this section where we're talking about integration. And the last thing we're going to talk about is a change in variables and multiple integrals. So basically what this section is doing, instead of just reading all of it, it's basically changing our double integral into a region that's really hard or not we're not able to do into a region that we're able to do. And this is a concept that extends from Calc 1. And so here you can see that concept where it's just U substitution. All right, so in Calc 1, when we were working on integrating functions that were a little bit difficult, we could use U substitution to make the problem look a little bit more easy, especially in the integration. And what we did here was, instead of, integrating over above the x-axis, what we would do is we would actually change the axis in which we were integrating, and we would integrate over a u-axis. And again, you're probably not told that in Calc 1, what you're actually integrating is you're changing the axis above what you're integrating. But it's something that I want to tell you, because when we're talking about integration or double integration, instead of integrating above an axis for a double integral, what you're doing is you're integrating above a surface. And so what we're going to have to do, or sorry, not a surface, well, you're integrating below a surface, but you're integrating above a region. And so, like U substitution, where we changed our variable to give us, a better axis that we can integrate above, that's the same concept that we're going to do here. We're going to change the region in which we're integrating above. And we're going to start off with the region that's going to be very, very difficult. So usually, the ones that we're going to change are going to be like an ellipsoid, and we're going to change that into, a circular region, because we can use polar to help us, double integrate that, the integral above that surface. Above that region. But for a paraboloid, it's going to be much more difficult. So we're going to be using this. So we're going to change paraboloids to, circular regions, ellipses to circular regions. Or what we're going to do is we're going to change like something like as a parallelogram. And again, we don't want to, integrate above that surface, because we're going to have to break up to, a few double integrals. We can change that parallelogram to be more of rectangular coordinates. Now the integration is not going to be very difficult. So that's what we're talking about. Is we're going to have a region that's really hard to integrate above, or could be impossible for us, to a region that's easier to deal with. And so that's why we do the change of variables. It's just like U substitution, but we're doing it with double integrals. All right, so usually what we do is we're going to take, usually we have a function, I'll just rewrite over here because it's easier if I write what we're doing. Usually what we're going to do is here you can see that we're doing it in terms of, we're switching to polar coordinates there. And then, of course, you have that RD theta. And so that's something that we're going to have to add on to the back end of all of these integrals as we're working on them. So, and that's going to be the Jacobian. And so I'll talk about a little bit more about that later. But, so basically what we're going to be doing, let me see if it's mentioned in the second part now. It's not. So what we're going to be doing is we're going to have a function in terms of x, y, and we're going to change this function in terms of, say, f of GU, f of GUV, H UV. So what we're doing is we're changing all of our our x and y's in terms of u and v, and we're going to be, taking the area above whatever that region is. But uv is going to be a region that's going to be easier to use. So again, instead of, we can call it u substitution, we're going to do uv substitution for double integrals. All right, again, and then that's mainly for rectangular. If we're going to change, an ellipse to, circular, then of course we would use, r and theta. All right, so the first thing that we're going to do is we're going to change what a transformation looks like. We're going to change we're going to change one region to another region. So here it says find the image of the set S under the given transformation. So usually we're going to start with, a region, and usually we call that region R, and we're going to translate that region R into a region S. And that region S is what we're going to integrate above, because it would be easier to integrate with respect to. So what we're going to do is we're going to find, okay, we're given S, and we want to find what was the original region that we were going to be working with. So I'm going to go ahead and draw this first region. And it's the rectangular region. We're going from, I'll go ahead and say that this is U, and this is V. All right. And again, this is how we're mainly going to do U and V's, because when we write it, it's usually UV, and when we write functions, it's XY. So since U's coming first, it'll be the horizontal axis. V will be the vertical axis. And so U is equal to 0 to 1. So U goes from 0 to 1, and so does V. So let's just go ahead and try to make those equidistant. And so that's 1, that's 1. And so our region is just going to be this square. And this is our region S, and let's go ahead and let's color that in. All right, now I'm going to define a few of these spots. So let's call this segment 1. And segment 1, if we define that, that's just going to be V equals 0. If I was to graph, this line right there, that's V equals 0. So this is segment 1. We can go ahead and call this segment 2. And segment 2 is going to be defined by U equals 1. Segment 3. And that's going to be defined by V equals 1. And then segment 4 is going to be defined by U equals 0. Sorry, I had to readjust my seats. Now, what we're going to do is we're going to draft the original region. And so we're going to start with these values. So our first value for segment 1 if V equals 0, then we're going to substitute in our values there. And so if V equals 0, X equals 0, because if X equals V, then X is going to equal 0. And then Y equals U plus 1 plus v squared, so 0 squared. So y is going to equal what u is, and u is defined for segment 1. U is defined between 0 to 1. So then y is going to be defined between 0 and 1. So let's go ahead and we'll graph that one. So down here, I'm going to graph region R. If that would go straight. All right. And so, why did that not work? All right, so this first one's just going to be x equals 0, and it's going to go all the way up to 1. I'll graph that in purple. So that was segment 1. And now let's try segment 2. Where segment 2 was defined by u equals 1. So here it's x equals v. And it stays x equals v. So this is going to be a region. And v was found to be between, on the v-axis, 0 and 1. So then x is going to be between 0 and 1. And then when we do y is equal to u, which we are saying u is 1. So 1 times 1 plus v squared. So that's just going to be y equals 1 plus, well, what do we know v to be? Well, v is just x, so it's just x squared. So here we have the parabola 1 plus x squared between 0 and 1 on the x. And so now, so if we plug in those values, the first one value we're going to get would be 0. The second value, would be 1, and the second value would be 2. So let's go ahead and extend that to 2. Segment 2 is going to start at 1. And again, we're going from 0 to 1 on the x-axis. So I'm going to extend that to 1. And again, plugging in our x values and it's going to be squared, so it's just going to be, it's going to start at 1, it's going to finish at 1, 2, and it's a parabola, so it's going to have that shape. So that's S2. Do S3. S3 we said was v equals 1. So it's going to be x equals v, which is just 1. And then y is just going to be u1 plus 1 squared. It's going to lead us to y equals 2u. And again, u is going between 0, in this case right here, we're going between 0 and 1 again. So that's what we're going to do. We're going to go in between the values 0 and 1. But now when we plug in 0, we're going to get 0. And when we plug in 1, we're going to get 2. So we have the equation x equals 1, and it goes from 0 to 2. So that's S3. S4, we have our last equation, u equals 0. So x is still going to be equal to v, and we're going to go between 0 and 1, because v goes between 0 and 1. And then we have y is equal to v, in this case, v is equal to u times 1 plus u squared. V squared. But if u is 0, then y is just going to equal 0. And so there's our equation for the final. Y equals 0. And we're going between 0 and 1. So that's S4. All right, and so there's our original region that we would have been working with. Did they use blue? Okay, let's just see blue. Not even on highlighter. So this is the original region that we would be working with. And that's region R. And so here you just see how we transformed from regions. A lot of times you're going to be given, the region, and then sometimes you're actually going to find it. The last example today, we're going to show how we're going to go between region R to region S, but mainly you're going to be given the values for region S in this section. All right, that does it for the first